Let's see one more method of handling the deadlock, that is deadlock detection algorithm. Here the system will not that will not employ deadlock prevention and deadlock avoidance. They can use deadlock detection algorithm. Okay, so this deadlock detection algorithm will be used after the deadlock has occurred in the system. Okay, so there are two types. First one, if a system that is having each resource have only one instance. Okay, that means there is only one printer, one scanner, one file that is shared, then we can use resource allocation graph, a modified version of resource allocation graph, that is using wait for graph we can find whether a deadlock occurred or not. And if the system having multiple instances of each resource, then we will use a modified version of banker's algorithm, a modified version of banker's algorithm to detect whether the system has errors or deadlock or not. If there is a deadlock, then there should be a recovery procedure. Okay, so there are two recovery procedures we will see later. Okay, so first we will see a single instance of each resource type whether a deadlock has been occurred or not. Okay, so here we will use a modified version of resource allocation graph, that is wait for graph. Okay, so in the resource allocation graph, there are processes and resources will consider it as vertices. Okay, but when it comes to wait for graph, we'll remove all the resources. Okay, and their corresponding edges. That means, see here, if there is a p1 to r1 and r1 to p2, p1 to r1 and r1 to p2, then in the wait for graph it will become p1 to p2. Okay, so p2 to r4, r4 to p3, then it will become p2 to p3. Okay, then p3 to r5, r5 to p4, then it will become p3 to p5. Okay, then sorry, p3 to p4. Okay, then p4 to r2, r2 to p1, p4 to r2, r2 to p1. Okay, so this will become one more. So there is a cycle here, and there is one more, that is p2 to r3, r3 to p5, so it will become p5. So this will be our wait for graph. So this, if we draw like this, we will get this particular graph. So we can find a lock, here. Okay, so a cycle here, we can find a cycle here. So p1 to p2, p2 to p3, p3 to p4, p4 to p1, there is a cycle here. Then p1, in between p1, p2, p4, there is a cycle, p2, p3, p4, and there is a cycle. So definitely there is a deadlock. Not one process here, there are multiple processes that are deadlock. See, even if you remove this one, even if you remove p2 to p4, still there is we can find a cycle here, p1, p2, p3, p4, and p1. Okay, so here we need to remove, if you remove this particular p2 completely, process completely, then still we'll get p1, p3, p4. Okay, so p2, if you remove it, maybe there is a chance of uh, avoid deadlocks. Okay, they recover from the deadlocks. Okay, this is one way. By using wait for graph, we can find whether a deadlock, here it is not recovery, how which process will be removed. Here we can find detect whether there is a deadlock occurred or not. That's our goal here. Okay, so next we can detect deadlocks but multiple instances. Okay, so this particular resource allocation graph or wait for graph is not suitable for resources with multiple instance. For that, again we need to go to modified version of banker's algorithm. Okay, so for the modified version of banker's algorithm, we'll use again we'll use some vectors and some matrices. Similar to banker's algorithm, there is an available matrix, allocation matrix. Here we will use request matrix. Okay, here we will use request matrix, and work is a vector, then finish is a array. Okay, so finish will take with number of processes, finish of I, where I is the number of process, we will take an array and will store whether the process is completed or whether the process is still to execute. If a value is true, then the process are already finished its execution. If a value is false, the process yet to completes its execution. Okay. Available means how many resources available currently. Allocation means how many resources are currently allocated to each process. So these three are actually matrices. Okay. So matrices of size n by m, where n is number of processes and m is number of resources. Okay, same as your banker's algorithm. So let's see the algorithm. Okay, so here it simply investigates every possible allocation of each and every process. Okay, and it will investigate it, the allocation sequence for the processes that remain to be completed. That means there are some processes which are completed, there are some processes which are not completed. It will check for complete not completed process. That means, see, let us take here, if allocation is 0, okay, allocation is 0, then the process has been completed its execution. If the allocation is not 0, then the process yet to complete its execution. But look at here. Okay, so 0 1 0 0 0 0, it doesn't need anything, but it will finish it. P0, it is not requesting anything. It is allocated 0 1 0, it is allocated 0 1 0. There are no more requests here, there are no more requests here. That means after a use of b, P0 will complete its execution and return this particular to this one. Okay, so here the first look at the algorithm. In the algorithm, again, as similar to your banker's algorithm, work equal to available. Okay, so how many resources are available, we will store it on work vector. Okay, and we will check the allocation matrix. We will check the allocation matrix. If any row have all zeros, okay, in the allocation, if any row which will have all zeros, then what is mean by that, that allocation of that particular row, assume that allocation of 2 consisting of all zeros, then we will say that allocation of 2, okay, is finished its execution. So we will use finish of 2 equal to false, sorry, true. Okay, otherwise we'll add finish of I equal to false. That means that particular process still to complete its execution, yet to complete its execution. Okay, otherwise we'll write finish of I equal to true. Okay, so we don't check this particular finish of I equal to, we only consider finish of I not equal to true. So we'll take one particular process, such process, that is finish of I equal to false, that is the process yet to complete execution. Then we'll check the request matrix. We'll check the request matrix, that is this one. Okay, we'll check the request matrix. Let us take P0. Okay, allocation is not equal allocation, you can say that finish of I not equal to true, finish of I not equal to true. But look at the request 0 0 0 is here. Okay, that means it is no request, it is not requesting anything. So if request, that is less than or equal to work. Okay, but look at here, even there are no available resources are there, still there are no available, both are zeros, request 0 and available 0. Then what will happen, look at here, 0 0 0, and even work is also 0 0, there are no currently available resources. Okay, then if this is true, yes, this is true, yes, then go to this one. So work equal to work plus allocation. What is allocation of 0? 0 1 0. Allocation of 0 is 0 1 0. So these 0 1 0 will be added to work, and work will become 0 1 0, and will make P0 is finished its execution. So finish of 0 equal to true, finish of 0 equal to true. Then we will go to next one, we will check for P1. Similarly, we will check for P2, we will check for P3, we will check for P4. So this thing, after completing P1 P2 P3 P4, okay, if there is any process which is not finishing its execution, okay, if there is any process which is not finishing its execution, how can you find it which is not finishing its execution? Still, how many times you how many rounds you go, okay, then you will find finish of something, some particular process is false only. Okay, then we can decide that the system is in deadlock state, the system is in deadlock state. Okay, otherwise if all are true, all are true, the system is not in deadlock state. Okay, if there is a system is in deadlock state and some particular process which is not completing its execution, we can say that that particular process, suppose that P3 is a process which is not completing its execution, it still has finish of 3 equal to false. Okay, that equal to false, we can say that P3 is causing the deadlock. P3 is causing the deadlock. So this, by using this particular algorithm, we can find which process is actually causing the deadlock. There is no rule that only one process will cause the deadlock. Okay, so there are multiple processes that may cause that is a reason for deadlock. Okay, system going to deadlock. So we can uh, after finding what are the processes which are causing the deadlock, we need to apply a recovery algorithm. Okay, deadlock recovery process. Okay, we need to start recovery process. Okay, so in the recovery process, we either will preempt the entire process or will preempt the resources. We'll apply two uh, two methods. First one, either we terminate the process or we terminate the resources. Okay, right? So first one, process termination. Okay, so one is about all the processes which are causing the deadlock. Okay, that is first one, but that causes a lot of problems. Okay, and which is considered as high cost mechanism. High cost mechanism, because if you terminate all the processes that is causing the deadlock, okay, this you there is a lot of time these deadlock processes are already used, okay, already executed. Okay, already executed, then you terminate that particular process and again restart the process. Again restart the process, it has to start execute that much time again. Okay, right? So then the best option for process termination is, instead of aborting all the processes at the same time, okay, we will abort one by one. We'll abort one by one. Okay, and let's and check whether the system is out of deadlock or not. Okay, one by one, and let's check the system is out of this deadlock state or not. So if some particular px is causing px, py, pz, three processes are causing the deadlock. First you terminate process px. Okay, then check using the same algorithm, deadlock detection algorithm, whether the system is and take all the resources of px. If you terminate px, means all the resources of px is taken by operating system, that is returned back to operating system. And check with the available resources. After taking these resources, px resources, that will be added to list of available resources. List of available resources. Check whether apply deadlock detection algorithm and check whether the system will come out of uh, deadlock state or not. Still if it is not come out, let's preempt one more resource and take its resources also. Take its resources also and apply deadlock detection algorithm. So after preempting each and every process, we will check whether the system is coming out of deadlock or not. Okay, so we'll terminate all the processes until the system is deadlock free. Okay, but how to find which process has to be removed? Okay, that depends upon a lot of factors. Okay, so first one, either the by checking the priority of that particular process. Okay, so some process by default they will have assigned to be some particular priority value. So high priority processes usually don't use for preemption or termination. Okay, so next one, how much longer that particular process has been executed and how much longer that process will be executed. We'll predict it, but we'll only take how much longer the process has been executed. Okay, then how many number of resources are used by that particular process. Number of resources are used by that particular process and how much time it has been used. Okay, and how many processes we need to terminate. Okay, that is also one thing, and what type of process we are terminating, that is interactive process, batch process. Using that particular type of process also, we can determine whether which process has to be terminated. Okay, there are several other factors we can select the victim process. Okay, you can select victim process. This has a lot of factors, that is based on lot of factors. Okay, so next one is resource preemption. Okay, so after uh, instead of preempting the entire process, instead of preempting the process, we'll preempt the resources here. That means we'll take the resources forcefully. Okay, suppose px has holding a b c resources. Okay, and py is waiting for a and b by holding d, and px is requesting for d. So this is not these three are at px and these two requested by pi, and px needs d and py holds d. So here, instead of terminating the entire process, we will take the resources first. We will take the resources from the process. Okay, so first one, we need to select the victim process to take the resources. Okay, so in the process termination, we determine the order of preemption to be minimized. Okay, that if you preempt the process, you need to select the minimum cost. That means the uh, suppose that here px and py, here px and py needs ab and holding d. Okay, so px holding abc and waiting for d. So if you preempt d from py, okay, d from py, so d will be given to px, d will be given to px, and px will use a b and d, c and d, a b c and d, and releases a and b, a and b, so that this ab as well as d will be given to py, will be given to py. So that is one way to select a victim process, where which process resources will be taken by operating system. Okay, so there are uh, there are one more operation that you need to do is rollback. The one more issue that we need to deal with preempting the resources is rollback, because if we preempt a resource, okay, suppose there is a process py, we are preempting the resource d. Okay, we are preempting the resource d. So once you preempt the resource, you cannot continue with that particular execution. Okay, so what you have to do, you need to, whatever the operations that are done, suppose that you have changed f1.txt and you have added some information here. Okay, some information here, and after that this particular px has modified this particular d. Okay, so while preempting it, whatever the modifications that are done by py on d file, on this particular file, you need to roll back, you need to clear that particular data. Okay, before giving it to px. So all the work, all the modifications that are done on a shared resource will be rolled back, will be rolled back, that means cancelled. It will be cancelled, and once you get d and you again restart and you again recompute, or you again remodify whatever the file that is whatever the resource that you get back. Okay, once you get back this particular resource, you start the work again. Okay, so there is one more issue called starvation. There is one more issue called starvation. That is, there is a process, suppose that a, okay, and pb and pc. There are three processes that are causing the deadlock, and there are some resources r1, r2, r2, r3, r3, r1. Okay, some resources are there. So there is a possibility that one particular process which will be always selected as a victim as resource preemption. Okay, that means suppose pa, so if pb needs r1, pb needs r1. Okay, and pc needs r2, pc needs r2. So at that time, first time you preempt pa, and r1 will be given to pb. So after some time, if pc will be asked for r2, you can preempt pb also, but you are preempting pa and giving it to r2. Okay, after some time, again pa claims r1 and r2, that is allocated r1 and r2. Some particular process px is requesting for r1, again you preempt pa. Okay, so this particular pa, if you preempt that particular resource, it has to roll back all the data that is performed on use all roll back all the data, okay, all the operations, and again you need to restart that particular work, and again it is given to some other process, and again you need to do same task that is you previously done. Okay, that will leads to PA in a starvation mode, because the work that is done by this the task of P1 that will not be completed, the process P1 that will not be completed. Okay, so you need to make sure that a process that is selected as victim process, okay, you need to select as victim process in resource preemption or process preemption. You need to make sure that there should be a limited or finite number of times you select that particular process. Once the finite number is exceeded, okay, you cannot select that process as victim process. You need to go other process for a victim process, selecting victim process. Okay, so this is recovery from the deadlock. Once you detect the deadlock, then you need to apply recovery process. So recovery process that involves two things: either we preempt the process, or we preempt the resources from the processes. Okay, so preempting the resources is better when it comes to preempting the entire process, because the cost of this particular cost of the system will be reduced by using resource preemption rather than complete termination of process, because you need to restart the process. Okay, right.